Hello and welcome to our DevOps with Go series. In this video we are diving into Docker, an essential tool in modern software development. Docker makes applications portable and consistent across different environments. And today we'll see how to containerize a simple Go application. Additionally, we'll explore how Go can automate Docker workflows, making your DevOps processes even more efficient. What are containers? Let's start by understanding containers. A container is a lightweight, standalone unit that packages everything an application needs to run: the code, runtime, libraries, and dependencies. This ensures that the application behaves the same way no matter where it's run, be it your local machine, a testing server, or production. Unlike virtual machines, containers share the host operating system, which makes them much faster and less resource intensive. Think of a container as a portable environment for your application, compact, efficient, and ready to go. Writing in Go application. Now that we understand containers, let's write a simple Go application that we'll later containerize. This Go program is a basic web server. When you visit it in your browser, it responds with "Hello Docker." In this code, we define a single HTTP handler, set up the server to listen on port 9090 and respond to every request. It's a simple program, but perfect for demonstrating the power of containers. Let's practice. Before we begin coding, we need to ensure that Go is installed on our machine. If you don't have Go installed yet, follow this step. Firstly, visit the official Go website and download the Go installer appropriate for your operation system, Windows, macOS, or Linux. Follow the installation instructions for your operation system. Once installed, you can verify that Go is installed by running the following command in your terminal. If Go is installed correctly, you'll see the version number in the output. First, let's create file main.go and declare the main package inside this file. Here we declare that this file belongs to the main package, which is essential for any Go application that will run directly. Next, let's import the libraries we need. We'll need the fmt package for formatted output and the net/http package to create the HTTP server. fmt is used to print text to the console or send output to an HTTP response. net/http is the core Go library for handling HTTP request and response. Now let's create the function that will handle the incoming HTTP requests. We will call this function handler. This function will be responsible for responding with the message "Hello, Docker and Go." The W parameter is of type http.responseWriter, which allows us to write the response back to the client. The R parameter is of type *http.request, which contains information about the incoming HTTP request, such as headers, URL, etc. Inside this function, we use fmt.fprintf to send a response to the user. This will be displayed in the browser when the client accesses our server. Now let's move on to starting the HTTP server. In the main function, we will register our handler function to be called when the root road is accessed. Then we will use http.listen and serve to start the server. http.handle function tells Go to use the handler function whenever a request is made to the root URL. http://listen and serve. Start the server and listen on port 9090. The server will now accept HTTP requests and call our handler function for any request to /. That's it. If you run this program, the server will be accessible on HTTP localhost 8080. When you visit the address in our browser, it will display hello Docker and Go. Okay, now let's run our HTTP server. We will use command go run and name of our file main.go. Our server is starting. Let's open the localhost in our browser, and now you can see that in browser displaying the hello Docker and Go. That's it for now. We have now created a simple HTTP server in Go. Next, we will containerize the application using Docker, and we will have a fully functional web server running in a container. Packaging with Docker. To run our HTTP server application in a container, we need to create a Docker file. The Docker file tells Docker how to build the container image. Let's practice again. Let's create Docker file. We start by specifying the base image. Here we are using the official Go image version 1.23. This gives us a pre-configured environment to compile and run Go programs, including all necessary tools and dependencies. We set the working directory inside the container to /app. This is where the source code will reside, and it will act as the current directory for any subsequent commands in the Docker file. If the directory doesn't exist, Docker will create it for us. This line copies all the files from the current local directory on the host machine into the working directory inside the container /app. This ensures that our source code and other required files are available in the container. Here we compile the Go application within the container. Go build compiles the source code. The -o app flag specifies that the output binary should be named app. This step produces an executable that we can run inside the container. This defines the default command to execute when the container starts. In this case, it runs the application binary ./app that we built in the previous step. This declares that the application inside the container will listen for incoming connections on port 9090. Note that this line is more of an informational hint and does not automatically publish the port. To make the application accessible, the port must be explicitly published using the docker run -p command. Once the image is ready, we can test it by running it as a container. First, we use the docker build command and the image name to create the image. Before using our command docker build, let's download the Docker desktop application. You need to go to website docker.com and download Docker desktop for your operation system. I already downloaded and I have run it. Before build our Docker image, let's build our Go application. Use Go mod init module name for build our Go application. Also, we can use another command, go mod td, which install requirement modules. Okay, now we can create our Docker image. We will use command docker build -t and our Docker image name. Now we see that our Docker image built. We can run the container with our Go HTTP server application. Our application now running. Let's open browser to check. In browser you can see greeting message from our application, and it means that our HTTP server running correctly. We see our application in action. This demonstrates the power of Docker. In just a few steps, our Go application is containerized and running seamlessly. Next, our practice will be automating Docker with Go. Let's create something more complicated than our simple HTTP server. Now, we will use Go to interact with Docker. Let's automate container lifecycle with Docker's Go SDK. I have created main.go file for our Go application and paste ready code in this file. Let's look in our code. We have error. It means that this remote modules not available now. Firstly, let's initialize our application using command go mod init and name of our application. Now we must use command go mod td for installing required dependencies. Before you see that we have some errors, red highlighting of our remote modules. After implementing go mod td, we downloaded all required modules. Let's look in our application. Before we begin automating Docker with Go, let's briefly cover the core Go concepts we'll be using in this program. If you are new to Go, don't worry, this section will give you enough context to follow along. Package and import statements. Every Go program starts with a main package, which defines the entry point for execution. Imports. The program imports several Go standard libraries and the Docker SDK. Context manages the lifecycle of API calls. FMT handles formatted input-output like printing. I/O for reading and writing streams of data. OS/exec runs shell commands used for Docker pull in this program. Strings provides string manipulation utilities. These modules enables interaction with the Docker API. Next one, the main function. The main function acts as the entry point of the program, initializes the Docker client using environment variables and version negotiation, creates a loop to show a simple text-based menu for managing Docker containers, captures user input and executes the appropriate action based on their choice. This piece of code is Docker client initialization. Creates a Docker client CLI to interact with the Docker daemon. From env loads connection settings from the environment. With API version negotiation ensures compatibility with different Docker API versions. Menu system. The program displays a menu and handles user input, prints a menu of actions, reads the user's input using fmt.scan, and executes the corresponding function. Start Nginx container. Docker pull pulls the latest Nginx image using a shell command. CLI.container creates a new container named Nginx container if it doesn't already exist. Error handling. Error handling for duplicate containers prompts the user to either use, remove, or exit, then the container name is already in use. CLI.container starts the container. Next function responsible for displaying list of containers. This function block retrieves a list of all containers using CLI container list. Prints the container's ID, name, and status. Next function restarts a container by its ID with a 10 seconds timeout for graceful shutdown. Next one stops the container with a similar timeout mechanism. Last function fetches logs of a specific container using CLI container logs and streams logs to the console. Okay, let's run our awesome application. Okay, let's check if we have already installed Go in our computer. Let's open terminal and use Go version command. Everything fine. And now let's ensure the Docker daemon is running. Docker info. Okay, we can see that's everything fine. We can see that our Docker desktop is running. And okay, let's build our Go application using command go build. And name of our application. Okay, now we can execute our program. Perfect. Once the program is running, let's use the interactive menu to demonstrate its feature. Option 1. The program pulls the Nginx image, if not already available, and starts a container named Nginx container. If the container already exists, it provides option 2. Remove and recreate the container, start the existing container, or return to the main menu. Let's check. You can see that a container with this name already exists. Let's choose option 1, remove existing container. Container removed, try again. Let's choose the first option again. Container started. Perfect. Let's choose option 2, view running containers. You can see a list of all running and stopped containers with their IDs, names, and statuses. Let's choose option 3, restart the container. Now by default, all the time work with Nginx container. Let's choose option 4, stops the Nginx container gracefully. Okay, next, let's choose option 5. Now displays logs from the Nginx container. Awesome. And last one, exit. Now we successfully exit from our Go program. That's it for today. Summary. Let's summarize what we covered today. Containers are lightweight and portable environments for running applications, and Docker is the tool that makes them easy to use. By writing a simple Go application and creating a Docker file, we learned how to build and run a containerized application. We also saw how Go can automate Docker tasks, making it a reliable language for DevOps engineers. As you work on your own projects, consider how you can use these tools to streamline development, testing, and deployment. Thanks for watching, and don't forget to like and subscribe for more videos on Go and DevOps. In the next video, we will dive deeper into Kubernetes API, and I'll show you how to build powerful automation workflows with Go. See you there!